So this is the all-in-one computer here that goes inside of the cabinet. This was going to be a real quick project that I was just going to kind of have on the side, but it turns out it was a little bit more involved than I had anticipated. But to give you an idea, this is laying down on its screen. It says at the back of the unit, this is where the VESA mount goes over here, and that's attached to the inside of the cabinet. And this device, a monitor and a computer in one, has a single power switch on this side over here. Now, I've already pre-disassembled this for the purpose of this video so we can kind of see, but when you take the back of the case off, you can see really what's inside of this. This is basically the computer over here, the RAM, the CPU, and all the components, whatnot. And then your hard drive and a couple of switches and interfaces over here. So the difficult part is that I've got to get this tiny little, see if I can get over here and you can see it, this little switch right there. And this is how the switch actuates. You can hear it click. And inside the switch, where I got the toothpick poked in here, there's an LED. So I knew when I was going into this that this was going to have 4 leads, 2 for the contacts, basically, when the 2 contacts meet, then it gives a signal to say, hey, it's time to turn the computer on. And then there'd be 2 more contacts that would power the LED inside of it. So I expected there to be 4 leads. And all I have to do is just get 2 wires to come off of that and somehow get that to the external portion of the computer. What I didn't expect was how incredibly small it was. So I flipped it over here and we can see that there's the switch. Now, these red things that are dangling, that's my work. But let me see if I can show you how small these leads are. I'm going to try to do this through this magnifying glass here. I don't know if that helps or not. I'll get my eyeball real close here and then we can see. But you can see how tight that is to get there. It's probably out of focus, but you get the idea. So I took these very fine wires here that I got for another project. I mean, these are so delicate. Just an errant pull is going to pull those things right off. So I was able to solder both of these on the inner leads, and then I put just a little bit of super glue here to try to keep it from breaking. But any errant movement, just tugging and pulling at it, it's going to pull that thing right off. So I had to come up with a way that we could, because I want an external switch on this. So that's the ultimate, the end goal. I'm going to put this to the side for a second. So basically, out of the side of the machine, this is where the switch is, right here where my finger is. We need some way to hit a mechanical switch so that it will give the signal, because I can't get my hand into the arcade machine when it has a big piece of Lexan over it and it's built into a wooden cabinet. So I came up with the idea. I've got those really fine wire leads on there, but I can't have those going outside of the machine. So I had one of these in the garage. It was just a little piece of a Molex, just a fancy term for the way that computers deliver power. It's like a little, I don't know, I think this powers something like some other device. I had a couple of these that I had kept for no other reason than just, I knew that one day I was going to cannibalize it for something. So I think what I'm going to do is I'm going to take this and I'm going to super glue this, I think, right here. And if you can imagine, and I'm going to have to chop, by the way, this is the bottom. This is where it's going to come out. I have to chop a hole, probably a little rectangle right there. That will be kind of poking out of a little rectangle hole. And then I've got another, of course, scrap piece in the garage. This is a temperature lead, a sensor that goes on a motherboard. So when you buy a motherboard, sometimes they have these things where you can check the temperature at certain points if you want it at the intake or touching a device. So I've got a number of these, but the important part is here on the end, and there is a kind of a standard spaced jumper, and lo and behold, it fits perfectly. So the idea is that there's going to be a hole that the user, myself, can plug this into, and it will make the contacts here. Of course, I'll chop off the temperature sensor, and this will be connected to a switch, I don't even know if I have the switch yet, but it'll be a momentary switch that will work to activate the computer, and it will be on the outside of the machine, which is the ultimate goal, by the way. So this will be a multiple part video once I get back to reassembling this and doing my soldering and the cutting and the super glue. I'll show you the work. See you in a bit. So here's the assembled finished product. This is with the shield on the back here, so it's all been reassembled. But you can see that the piece has been super glued on there, and that worked out pretty well. The very fine wires went in between. I used a piece of duct tape to kind of help with the strain relief, and it loops around and goes under. And then it's soldered to these points here. Certainly not my best solder job, but it will get the job done. And then the idea is that the plug will come from the outside, which looks like this, and then that basically inserts this way, and that will stick out of the bottom. So in order to do that, I had to modify with a very ugly hole, but it should line up just fine and won't detract from the aesthetics of the device. So the only other complication that I had was after all the gluing and playing with this, that the pins got kind of loose and they were sliding back and forth in here. So I had to do like a little bit of a bend. If you look, you can see that it's straight here, and then it bends down, kind of does 45 and 45, so that it doesn't slide in and out. The worst case is that these things are moving. These are very delicate solder joints right there, so we don't want those moving around. But that should work. I'll get this all reassembled and put a switch on it, and we will see if it activates. So here is the finished product. This is the AIO turned over on its back. I reinstalled the VESA mount, which that's how it connects to the machine. And then here's the power supply. This is what I ended up with here. It's a hole with 2 pins. And then in the garage, quickly I made a momentary switch. Basically, it's off until it clicks in, and then it's off when it comes back out. And this is the lead that I had prior with the jumper style kind of lead at the end. So the idea is that this it would still work if you push the traditional button over here, no problem. But we're going to take this and do our best to connect it kind of in the dark. Once I feel it bite a little bit, now that buries in there pretty deep. Okay, so that's connected now. So in theory, this will be connected to like the machine through a panel or something along the way. So we click this button one time, and you can see the reaction of the LEDs on the side if it's working properly. And there's an LED, and the screen lit up. It's now in its boot sequence. So this switch does not disable the onboard switch in any way. So if you unplug this, it goes right back to the way it was. But this would be kind of floating in the cabinet, plugged in, and have enough of a lead to where you could spin it around and move it. But you can see Windows booted up, no problem. And it does also respond to the shutdown signal as well. So it makes it nice to have the cabinet and a switch that I can control the machine from the external. So if it's give it a click, and it saw that, and it's shutting down now as a result. So that'll go into the cabinet, and I'll show you how that looks a little bit later, as when we continue with the internal components.